Good morning. We are now studying few concepts of astrophysics, among which we now study the Hertzsprung-Russell diagram, or otherwise known as HR diagram. Hertzsprung and Russell were the two astrophysicists who plotted the absolute magnitudes, or otherwise the luminosity, as a function of surface temperature of the stars. The diagram or graph so obtained is called the HR diagram. The diagram obtained by plotting the absolute magnitudes, or otherwise the absolute luminosities, versus the surface temperature in Kelvin. Every dot in this diagram represents a star. From the HR diagram, we can observe that 90% of the stars are located on a diagonal band that runs from the left top corner to the right bottom corner. There is a diagonal band from left top corner to the right bottom corner. On that diagonal band, 90% of the stars exist. And this diagonal band is called main sequence. Supergiants, normal giants, subgiants, etc. lie above the main sequence. You can see here all the giants are above the main sequence, and white dwarfs, subdwarfs lie below the main sequence. Nearly about 90% of the stars lie on the diagonal band, which runs from top left corner to the right bottom corner, and this band we call it as the main sequence. So among the main sequence stars, red dwarfs are more common and blue giants are very rare. Most of the stars which are on the main sequence are red dwarfs. Only a few are blue giants. And all main sequence stars are said to be in the hydrostatic equilibrium. Meaning the stars are said to be in hydrostatic equilibrium when the outward thermal pressure due to the hot core is balanced by the inward gravitational pressure due to the outer layers of the star. When this condition is satisfied, the stars are said to be in hydrostatic equilibrium. And all the stars in the main sequence are said to obey this condition. The outward thermal pressure due to the hot core will be balanced by the inward gravitational pressure due to the outer layers of the star. The main sequence is divided into two parts, one the upper part and the other lower part, based on the type of energy released. Stars with mass below 1.5 times the solar mass, stars with masses below 1.5 times the solar masses, fusion of hydrogen takes place in a series of stages called proton-proton cycle. Stars located in the lower part of the main sequence will have this possibility, whereas stars with masses larger than 1.5 times the solar masses are located in the upper part of the main sequence. And in these stars, the fusion process mainly makes use of carbon, nitrogen and oxygen atoms as the intermediates to form the helium. So the conclusion is stars with lesser masses will occupy the lower part of the main sequence, whereas stars with larger masses occupy the main sequence. Stars in the lower part release energy by the fusion of hydrogen atoms through a cycle called proton-proton cycle. Whereas stars in the upper part of the main sequence release energy due to the fusion of hydrogen nuclei again, which makes use of carbon, nitrogen, oxygen as intermediates, or release energy through a cycle known as CNO cycle. Now, main sequence stars with mass larger than twice the solar mass will undergo convection in their core and maintain fuel proportion required for the fusion. Below this mass, stars have cores entirely radiative with convective zones near the surface. With decreasing stellar mass proportion, the convective envelope increases. Stars with masses below 0.4 times the solar mass undergo convection throughout the star. When the core convection does not occur, a helium-rich core develops surrounded by the outer layers of hydrogen atoms. If the luminosity of the star is larger than 10 power 6 times the luminosity of the sun, then this star corresponds to a mass larger than 60 times the solar mass. If that is the case, then the pressure generated by the photons is great enough to remove significant amounts of mass from the outer layers of the star until the mass reduces to 60 times the solar mass and the luminosity reduces to 10 power 6 times the luminosity of the star. Mass of main sequence star determines its temperature. It also determines the brightness. The mass of the main sequence star determines its temperature as well as brightness and also its position on the HR diagram. Larger masses on the upper part, lower masses on the lower part of the HR diagram. Similarly, the temperature and brightness. The star is on the upper part, the temperature and brightness is more, luminosity is more. If the star is on the lower part of the main sequence, the temperature, brightness, luminosity are lesser. And also, if the mass of the stars is more, it is said to have shorter lifespan on the main sequence. They will move out of the main sequence early. After the hydrogen fuel at the core is burnt out, the star moves away from the main sequence. Stars with masses below 0.23 times the solar mass directly becomes white dwarfs. So you can see here, once the hydrogen fuel at the core is totally burnt out, the star will no longer remain in the main sequence. It will automatically move out of the main sequence. If the mass of the star is below 0.23 times the solar mass, then such a star will directly become white dwarfs. And stars with masses up to 10 times the solar mass pass through a stage known as red giant stage. If the mass of the star is larger than this, then the star will have the chance of exploding as supernova, or the other probability is it may directly collapse into a black hole. It collapses itself to become a black hole. The mass is larger than this 10 times solar mass. There are two possibilities. One possibility is it may explode a supernova or it may collapse into a black hole. And these are the few characteristics of main sequence stars. The main sequence stars determines its temperature, brightness, its luminosity, its position on the HR diagram. Main sequence is nothing but a continuous band of stars that appears color and is known as the magnitude plots. Main sequence is divided into two parts, one the upper part and the other the lower part, based on the method of release of energy. Stars of mass below 1.5 times solar mass, fusion of hydrogen takes place in a series of stages called proton-proton cycle. And stars of masses above 1.4 times solar mass, which lie in the upper sequence, fusion takes place with the help of intermediate atoms, carbon, nitrogen, oxygen, through the CNO cycle to form helium. And main sequence stars below 0.4 times solar mass undergo convection throughout their mass, and main sequence stars with mass more than 2 times solar mass undergo convection only in their core. This is about the characteristics of main sequence stars. Thank you.